The NEET 2019 question from kinetic theory of gases. The problem says the value of gamma for hydrogen, helium, and another ideal diatomic gas X, whose molecules are not rigid and also vibrating, is respectively equal to how much, right? So to find the value of the gamma, if you go back to the basics, we know gamma equal to Cp by Cv. So I need to know Cp and Cv so that I can find the value of the gamma. For that, we can go to the definition of Cv first. That's the amount of the heat energy required to raise the temperature of unit mole of the gas by 1 degree centigrade at constant volume. We know as for the first law of thermodynamics, dq equal to du plus dw. dw can be written like dv, pdv. As a constant volume, dv equal to 0. So pdv also becomes 0. So dq becomes du plus pdv equal to 0. That equal to du. So I can rewrite the Cv equation as 1 by n du by dt. Right? Now I can further write for 1 mole of ideal gas, Cv equal to 1 by 1 du by dt. According to the free energy distribution, for each degree of freedom, there is an internal energy equal to half of R d. If F is degree of freedom, then the total du is equal to F by 2 R dt. Substituting this in this equation makes Cv as 1 into F by 2 R dt by dt is there. So dt cancels. So Cv equal to F by 2 times of R. And we also know Cp minus Cv equal to R. So Cp equal to Cv plus R. We already found Cv as F by 2 of R. Plus R has to be made. So F by 2 plus 1 times of R. Now I got Cp. I know Cv. So I can get the value of gamma as what? That implies gamma in terms of degrees of freedom is Cp is F by 2 plus 1 times of R by Cv is F by 2 times of R. R gets cancels. So gamma equal to, if I take 2 as LCM, F plus 2 by F by 2. 2 cancels. F by 2 by F. So gamma equal to 1 plus 2 by F is the formula which I need to use to find the value of gamma for different gases, where be careful, F is called degree of freedom. Once you understand this basic aspect, then we can go to the problem, right? For example, for hydrogen, hydrogen is generally in the format of H2. It is a diatomic. Similarly, next we are having helium. I will write here for helium He. So that is monoatomic. Now starting with helium, for a monoatomic gas molecule, it can move either along x-axis, along y-axis, or move along z-axis. Being a single molecule, it has only translatory motion along 3 possible directions. So it has 3 degrees of freedom in translatory motion. As a single molecule, its rotatory motion is not there. its vibratory motion is also not there. So for helium, total degree of freedom is 3. Once if you know that, I can use this formula. Gamma of helium is 1 plus 2 by F, that is 1 plus 2 by 3, that is 5 by 3. So for the second one that was mentioned, helium is 5 by 3, that is there in this option and this option. So for hydrogen, when somebody is saying 5 by 3, that's wrong. These two options are already ruled out. Remaining two options has to be worked out. Let's work out about helium. Now I can talk about hydrogen here, who is a diatomic gas molecule. Being a diatomic gas molecule, it can have, the system can have translatory motion along x-axis, translatory motion along y-axis, and also have a translatory motion along z-axis, right? Now, about the rotatory motion, that what I need to say, it can, taking this as one axis, this particle can rotate around it. That is 1 degree of freedom. The other possibility is taking this as an axis, this also can rotate around it. So it has translatory motion 3 degrees of freedom, rotatory motion 2 degrees of freedom, vibratory motion is generally not there. So it has a total degree of freedom of 5. So gamma of hydrogen, I can again use this formula 1 plus 2 by F, 1 plus 2 by 5, that is 7 by 5. So the first one has to start with 7 by 5. Unfortunately, both the options are starting with 7 by 5 itself. So I cannot eliminate the option, any of the options basing on that. So I shall proceed for the next part of the option that is given for you. What is that next part is given for you is the third particle is given for you as another ideal diatomic gas X, name is not given, whose molecules are not rigid but have an additional vibratory mode also. They can also vibrate. That's what he is saying, right? So for molecule, for X, it has a translatory motion too, like any helium. It has rotatory motion too, like helium. And being it is, they are not fixed. They have a vibratory motion too. They can vibrate about a point. Therefore, one molecule can vibrate this way. The other molecule also can vibrate this way. So it has 2 degrees of freedom. Of course, and they can vibrate along x-axis, y-axis, and z-axis. So they have 3 degrees of freedom actually. So together they have degrees of freedom of 7. Then gamma of that x becomes 1 plus 2 by F, that is 7. That is 9 by 7. So 9 by 7 is available here. That's the right option. Here 7 by 5 is there. That is wrong. Right? The answer for the problem is this. Therefore, while we are solving this problem, we have explained a lot of concepts. The concepts that we have explained is how do you get this formula for the gamma in terms of degrees of freedom, and how do you consider degrees of freedom for a diatomic, monoatomic, and diatomic with vibratory motion as it is given in the problem. Right? These are the things that you need to know to solve this problem. Thank you for watching. Right.